problem. A point is 40 mm behind VP, 15 mm in front, 15 mm above HP, and 25 mm in front or behind or from LPP. Draw its projections and name the side view. So this is a case wherein it is behind VP above HP. So it is in second quadrant. And he says it is 25 mm in front or behind or from LPP. So it is LPP. So obviously this should be to the, when you look from the front view, the left profile plane to be towards the left side of the viewing direction. So that is the reason why LPP is on this side. This is VP and this is horizontal plane. Now this is the case in second quadrant because behind VP and above HP. Now as the case says it is behind VP, so obviously it should be behind LPP. So now we will go to analyze this. To do that, we have to have the condition of observer. So what is the condition of the observer? If you look from the front view, so that means the observer is looking from the front. Then the plane is between the object and the observer. Similarly, when you look from the top view, object is between the plane and the observer. Because when you look from the front view, the viewing direction is perpendicular to the vertical plane. And when you look from the top view, the viewing direction is perpendicular to the horizontal plane. Now, there are two cases wherein viewing direction is perpendicular to the left profile plane. One is the left side view and the other one is the right side view. So, if you consider the left side view, plane is between the object and the observer. When you consider the right side view, object is between the plane and the observer. So, always it should satisfy the condition of the front view. That means when you look from the front view, plane is between the object and the observer. So that condition has to be satisfied. If that condition has to be satisfied, then I have to look from the left side view. In left side view, what happens is the plane is between the object and the observer. Since the viewing direction is perpendicular to the, we are looking from the left side view. So obviously the object is behind LPP. So behind VP, so behind LPP. So that is how we can analyze that. This should be the left side view. Now, when you consider from the front view, the distance is above HP. So 15 mm above HP distance, which is, when you look from the front view, can be seen here. So that image will going to fall on the vertical plane. Then when you look from the top view, we can see the distance behind VP. So that is the distance from here to here. That distance is 40 mm behind VP. That image will going to fall on the horizontal plane. So that is the top view. Then 25 mm in front or behind or from LPP. As we have said that it is behind LPP. So when you look from the left side view, we can see the distance above HP. That is this distance that can be seen here. And also when you look from the left side view, we can see the distance behind VP, so which is the distance which is 40 mm. So this 40 mm can be seen here. And this is how. And when you look from the front view, we can see the distance behind LPP, that is this distance is visible or is seen here. And also when you look from the top view, we can see the distance behind LPP. So this is how we can analyze this problem in 3 dimensions. But now here, when it is how to rotate, so we are cutting here, then the horizontal plane is rotated above and the left profile plane is rotated in anti-clockwise direction such that the LPP will be aligned with the vertical plane. So that is how, this is the intermediate position what we have shown here. Then when you see in the step 3, so VP and HP will be overlapping and the left side view will come to the left side. Always left profile plane will be adjacent to VP. So VP is being fixed. Now we can see that the distance above HP, which is 15 mm. So that distance which is the above HP means the image will going to fall on the vertical plane. Since the image is on vertical plane, so that means it becomes the front view. So that is P dash. And also when you look from the top view, we can see the distance behind VP. That behind VP distance will be falling on horizontal plane. So that distance which you see is the top view. Therefore, it will be small p. The distance behind LPP, which can be seen in both VP and as well as in HP. So that distance is 25 mm. So we are considering the 25 mm here. And then when you look from the side view, both the front view and side view will going to be on the same line. Why? Because in the left side view, we can see the distance above HP, and also we can see the distance behind VP. So when P dash and P double dash will be always on the same line. So here, when you are projecting from P dash to the profile view, you are going to get this distance, which will going to be 15 mm. And then when it is projected that the top view point, because in the side view both we can see the top view and as well as the front view. The front view distance is above HP by 15 and the top view distance is behind VP by 40. So now when you are projecting this till here, so you are getting this distance which is 40 mm. But this 40 mm which is vertical here has to be transferred to horizontal distance. So to do that, first you draw an inclined line at an angle of 45 degrees so that it will going to come and touches this point. And where you can see whatever the distance which is 40 mm is vertical here has been transferred to the horizontal distance here. And then where you have the front view, on that line you will going to get the side view. So now here we know the distance behind VP is the distance what we have taken, and the distance above HP is here. So here when you are projecting this point here directly, and this distance will be above HP by 15 mm, and this distance in front of behind VP by 40 mm. Because this distance and this distance both will going to be same because they are parallel. So this is the side view what you are going to get, which will going to be P double dash. And then the side view what you are going to write is LSV, because that is behind LPP. And this is how we can be able to analyze this problem in 3 dimensions. We will going to analyze this in the final solution, how we can write it in the sketchbook. So here, to write it in the sketchbook, first we will going to draw the XY line and X1, Y1 line with a thin lines. Then the distance with respect to LPP, that is behind LPP, is seen in both HP and VP. So first we are going to mark VP and HP. HP is the one in bracket. That is basically because the horizontal plane is the one which has been rotated, which has been visualized in step 2. And then LPP is towards the left side. Always LPP will going to be the adjacent to VP. If VP is above XY line, LPP will also be above XY line. If VP is below XY line, then LPP is also below XY line. That we are going to see in the next part. Now, once you mark the XY and X1, Y1 line and marking VP and HP in bracket and LPP, now we will going to solve the problem. The distance behind LPP, which can be seen in both VP and HP. So from X1, Y1 line, you measure the distance of 25 mm and draw a vertical projector, which is as shown. Then the distance above HP is 15 mm. So from here, XY line, you measure the distance above HP of 15 mm. Since it is above HP, so obviously that becomes the front view, because the image will going to be seen in the vertical plane. The vertical plane is also above XY line. Therefore, from here you measure the distance of 15 mm and mark this point. Since the image is on vertical plane, so obviously that will going to be the front view. So we will going to write it as P dash. Then the distance behind VP is 40 mm. So from XY line, you measure the distance of 40 mm and mark this point. So this point will going to be P. And we know the distance of 25 mm, which has been already told. Now we will going to write the side view. So to write the side view, in the side view what happens? We can see the distances of both front view and as well as the top view. That means the distance above HP of 15 mm can be seen in the, which is seen in the front view, is also seen in this profile view. And the distance behind VP, which is seen on HP here, that also can be seen in the profile view. So to do that, here the distance above HP is 15 mm, which is vertical. Even in the final stage, even in the side view also, it will be above HP by 15 mm. So that means here also it is vertical and here also it is vertical. So you draw a horizontal projector from P dash to the profile view. Then since I need to transfer this distance, which is 40 mm, which is vertical here, has to be transferred onto horizontal distance, that is this distance. So to do that, first we are going to draw a 45 degree line adjacent to HP. That is basically because the the image which is in HP is the one which you need to transfer to the side view. So you may draw a 45-degree line adjacent to HP and then draw a horizontal projector from P to the 45-degree line first. Then from here you draw a vertical projector such that both P dash and P double dash will going to be on the same line. That is also quite evident from the step 3. And then here we can see this distance is above HP, which is 15 mm, and this distance it is behind VP, which is 40 mm. And since it is behind VP, so obviously the view what you are going to get is the left side view. So this and right left side view and give the dimensions and draw the directions of projection which is as shown. So this will going to be the final solution which is need to be written in the sketchbook.